Are you ready for the ultimate logic test? Let's see if our viewers can actually pass this. Okay, Sam, the Monty Hall classic. You pick a door, the host shows a goat behind another, then offers a switch. What do you do? Most people think it's a coin flip now, right? 50-50 chance. But I have a feeling there's a catch. The correct answer is actually to switch. Explain that, because it feels like it shouldn't matter. Initially, you had a 1/3 chance. The host's move concentrates the remaining 2/3 probability into the door you didn't pick. Alex, Sam, imagine a small party of 23 people. What are the odds to share a birthday? There are 365 days in a year, so for only 23 people, it has to be a very low percentage. It is actually 50%. Wait, how? 23 is such a small number compared to 365. It's about the number of pairs. With 23 people, you have over 250 possible pairings to find a match. Alex, Zeno argued that Achilles can never catch a tortoise because he has to reach where it was first, but it always moves a bit further. Logically, it sounds like an infinite chase, but we know humans outrun turtles. What's the trick? The answer is yes, in finite time. So the infinite steps don't take infinite time? Exactly. Calculus shows that summing an infinite series of smaller and smaller durations results in a finite number. You get a positive result on a 99% accurate test for a super rare disease. How worried are you? 99% sounds like a death sentence. I'd be terrified. Actually, your chance is only about 1%. That's a huge relief, but the math seems broken. Because the disease is so rare, the 1% error rate on the healthy population produces way more false positives than true ones. Sam, if I double your prize for every tails you flip before a head, how much would you pay to play? I mean, I could win millions if I'm lucky, but I'll probably just get $2. Maybe I'd pay $5? The mathematical fair price is infinity. Infinity? That's impossible. I'd lose my house for a 50% chance at $2. That's why it's a paradox. The expected value is infinite, but the utility to a human is very low. Level 2. The questions are getting much harder now. I doubt anyone gets a perfect score from here on out. 3 guys pay $30, get 3 back, so they pay $27. The bellboy kept 2. 27 plus 2 is 29. Where is the 30th dollar? Wait, 30 minus 3 is 27, plus the 2, that's definitely 29. My brain is melting. The trick is in the framing. You don't add the $2 to the 27. Why not? That's how we total it. No, the 27 they spent already includes the 2 the bellboy took. You subtract the 2 to find the 25 the hotel kept. If you have 100 candidates and have to choose immediately, what's the best strategy to find the number 1 person? If I wait too long, I lose them. If I pick too early, I miss the talent. Maybe half? The magic number is 37. Why 37 specifically? It's based on the mathematical constant E. Reject the first 37%, then hire the next person who's better than everyone you saw before.
You have $100 in your envelope. The other has either $50 or $200. Mathematically, the average of those is $125. Do you switch? If the average is higher than what I have, switching seems like a no-brainer. But why does it feel like a trick?
It's a famous paradox. If you switch, the math says you win, but then you'd want to switch back immediately. So the math is lying? Not lying, but it misuses probability by assuming both double and half are equally likely in all scenarios. Wing A has better survival rates for men and better for women than Wing B. Does that mean Wing A is safer? If it's better for both groups, it has to be better for the whole hospital. That's just common sense.
Actually, Wing B could be safer overall. This is Simpson's paradox. How can the total be lower if every part is higher? If Wing B treats way more men who have higher survival rates than Wing A does, the weighted average flips.
Alex's sleeping beauty is woken up. She doesn't know if it's the first or second time. What should she bet the coin was? A coin is always 50-50. Being woken up doesn't change the metal coin in the air.
Most mathematicians say it's 1/3. 1/3, but there are only two sides to a coin. Because if the experiment is repeated many times, she wakes up on tails twice as often as on heads.
The final gauntlet. Only the top 1% will survive these. Good luck, you'll need it. Sam, what's the probability a random line in a circle is long? 1/2, 1/3, or 1/4? Well, it depends on how you draw the line, but there should only be one true answer. The answer is actually all of them, depending on your method. That's not how math works. You can't have 3 different probabilities for the same thing. Bertrand's paradox proves that the word random is ambiguous in geometry, unless you define the process. Look at all the numbers in a newspaper. What digit do you think most of them start with? I'd assume it's a random spread. 1 through 9 should each be about 11%. It's actually the number 1, nearly 30% of the time. That sounds like a glitch in the universe. Why 1? It's Benford's law. In logarithmic growth, you spend much more time moving from 1 to 2 than from 8 to 9. Statistically, your friends are probably more popular than you are. Does that hurt to hear? It sounds like a personal insult, but is there a math reason for it? It's the friendship paradox. Popular people, by definition, belong to more friend groups.
So they show up in more average counts?
Exactly. You're more likely to be friends with someone who has many friends than someone who has none. 100 prisoners, 100 boxes. They only get to open half. If they pick randomly, the chance they all succeed is practically 0. It's like 0.0000000001 or something. There's no way they survive. If they use a strategy called cycle following, their odds jump to over 31%. 31% from nearly 0? How can a strategy change the contents of a box? It doesn't change the boxes, but it ensures their failures and successes are coupled together. Sam,
You have 100 pounds of potatoes. They are 99% water. You dry them slightly until they are 98% water. New weight? I mean, 99 to 98%, it's a 1% difference. So 99 pounds? Wait, we're not giving them the answer to this one. Nope. Let us know what you think the answer is down in the comments.
Did you solve that final barber paradox? Let us know your score in the comments. Don't forget to subscribe for more brain-breaking logic.